So I think that maybe you'll like that because that's a little bit of a step out of proofwriting world for a little bit. I do feel sorry for some of you who are in real analysis at the same time. It's a hard. The good thing is whatever you're doing in here should help you for your thinking for real analysis. And real analysis is the tougher class, no doubt about it. All right. It's fun though. So look at it this way. There's a percentage of you who are going to come back. And I would like you to come back and teach these kind of courses in uniform. The real analysis and these kind of courses, because if you master it here, you won't be afraid of it in graduate school. It's the same thinking. You can take any proofwriting class and now it's the same thinking. So if you take combinatorics or algebra, you already know how to write a proof, you know how to structure it, and that's like 90% of it right there, is knowing what you have to do. Or what kind of questions to ask. I think that was the toughest thing. Like, I don't even know what to ask when I started out the proofwriting classes. So it's not the worst thing in the world. Yeah, a little bit. There's going to be crying. That's what someone said. Well, 1 month of crying, no matter what we say at the beginning. Get it over with here at West Point, and then meet it head on wherever else you're at. Okay, so this is a step-by-step example. I'm going to give you a board problem, so it's a little bit of monkey see, monkey do today, which is kind of a welcome breath of fresh air. I looked at some of the problems she asked, though, and so I think I need to ask you more tough-looking integration. So I'll put some, we'll do it on Wednesday, maybe some more difficult-looking integrals in the context of what we're covering that day. Here we have a joint distribution, a joint PDF probability density function. And the first one's just to find the constant. So Colonel Watts actually took the approach of having her students discover and build it up. I was a little bit more methodical. I took the book and used the definition. So it might be statistician versus mathematician here. But what you do is you take the definition of PDF. It's a double integral. You see me set up the limits of integration. That's a requirement for your homework. Those limits must be indicated. That you're integrating from y2 to y2 here and y1 to y1 here. It's for you and I both, so that I can read your work and know what happened if something went wrong. So another thing is that these two must match. So your integrand, the dy2 has to match with the y2 here. So watch your notation on this one. That total probability, I just, go ahead.
Why are you integrating from 0 to 6? Y1?
Oh, it should be 2 to 6. I proofread even your board sheet, so I don't have any LaTeX errors in that. I still did it. So this should be 2 here to 6. So, but I integrated correctly. So this answer is 210C. And I used the Wolfram Alpha's double integral calculator. It's not part of Wolfram Alpha. It's a separate little thing. But I talked to Colonel Clark, and they're going to allow you to use Mathematica on your quiz. So you set that equal to 1, and then you solve for C. C is 1 over 210. Question?
Ma'am, you can say that it's equal to 1 because of the total probability.
That's what the total, so this should be, somebody asked Colin Clark if they should go from minus infinity to infinity, and I think we came up with a problem where it actually makes a difference. So this, I should have actually had a integral here that starts from minus infinity to infinity on both of the integration pieces, and then it turns out to be this because it's 0 otherwise, so those pieces drop off, and then that total integral has to be equal to 1.
And do you think that we could see a trade-off in one aspect of the quiz now that we could use Wolfram?
Let me ask them because it's, I have no problem with it if you use just Wolfram Alpha's double integral calculator. But let me ask them if you can. So, because that's the internet, right? So they usually have at the head of everything, don't use accept the internet.
Yes.
All right, so that's my new PDF right up here. So I actually was feeling bad now after listening to Colonel Watts because she had her students build up what they thought E of Y1 should look like. But I went straight to the book and looked up the definition. And they have a crazy definition. If you look on page 256, you have a hard copy of your book, just share with each other and look at it. It's like a crazy looking thing. And I think he just got lazy and didn't want to write two theorems or two separate definitions and one theorem or something after it. But he defines expected value of g of y1 comma y2. So he has multiple functions, and then he has an extended list of variables. So he must have got tired of typing in LaTeX and just said, I'm just going to write it down all at once. But if you pull that definition, that function that we're looking at is g of y1 comma y2 equals y1. If you are a 205 fan, this is the projection function. Vector calculus also, you'll hit this. This is a projection function. You're projecting on the y1 plane. So e of y1, if I plug it right into the formula that they have, it's this formula right here. So that's not how they have it written in the book. They have this long formula. I really recommend you look at it because it's one of those, hey, how do I dissect that formula apart? Because it has a bunch of G1s and G2s and subscripts and multiple, like it has n different variables, not just two. So that's y1 because I'm projecting down. And f of y1 comma y2 turns out to be this guy over here. And of course I need my 1 over, I don't like constants.